The current Wikipedia article on Ivan Pavlov is extremely brief in nature. It scarcely summarizes a few key aspects of his life and work. Also, the current subheadings are either too vague or inappropriate for the information their given sections entail. The section entitled Life and Research will be split in two and renamed Biographical Information and Pavlov's Dogs and the Conditioned Response. The section simply titled Legacy is misleading considering its scattered facts. It will be renamed Pavlov's Contributions to Psychology and the Biological Sciences. All information from this section falling outside the advancement of psychological knowledge, in particular, will be placed in another new section titled Other Facts. The section entitled Reflex System Research will be left as it is.
Выйду предалина, в небо погляжу и платочком пестрым косы повяжу.
For the first of the new subheadings, Biographical Information, I intend to greatly add to the current material, particularly with biographical facts which draw a sketch of Pavlov as an individual. Ivan Petrovich Pavlov was born September 14th, 1849, to Pyotr and Varvara Pavlov. He was the firstborn of 11 children. His father was an Eastern Orthodox priest, while his mother was the daughter of one. Pavlov's birthplace was the Russian territory, or province of Ryazan, in its capital city with the same name. The purported psychological effects of a childhood trauma in which he injured his skull prevented him from attending school until age 11. Despite being an Orthodox priest, Pyotr was very liberal-minded. He was also very humanitarian in nature. These are two characteristics said to have rubbed off on his son. In 1860, Pavlov began attending a local theological seminary, or college where one prepares to become a priest, like his father. At the seminary, on top of the required religious teachings, students could choose a particular path of study, and due to the works of particular individuals studied by Pavlov, he chose the natural sciences. In 1870, Pavlov enrolled at the University of St. Petersburg with animal physiology as his major and chemistry as his minor. After winning an esteemed award, or gold medal, for his physiological work on the pancreas, he turned down the chance to become a doctor of medicine after he felt his supervising professor was unjustly dismissed. He also desired to continue his research work, and therefore began studying veterinary medicine at the Academy of Medical Surgery. There, he was awarded another gold medal, and in 1878 began collaborating with renowned clinician Professor Botkin. Due to a lack of financing for research in Tsarist Russia, Pavlov literally had to sleep on the floor of Botkin's lab at night. This continued for years, even after marrying his wife Serafina. Serafina lived at Pavlov's brother's house. In 1883, Pavlov completed his doctorate on the centrifugal nerves of the heart. That same year, his son Mertnik was born, who later died on a voyage to the countryside with his mother. Pavlov spent the scholarship money from his doctorate on a 2-year visit of the laboratories in Germany, including that of Karl Ludwig in Leipzig. It was upon his return that his interest turned to the study of saliva and gastric juices. In 1890, Pavlov became chair of pharmacology at the Military Medical Academy and chair of physiology at the Institute of Experimental Medicine. The latter of the two is where he conducted his most famous work on gastric juice and salivary secretion on dogs. In 1904, Pavlov was awarded the Nobel Prize in Medicine for his work on the digestive system. Pavlov was described as being a radical behaviorist, much like his successors John Watson and B.F. Skinner. He believed that he could explain all animal behavior through instinctual and conditioned reflexes. However, according to some sources, Pavlov admitted that there are decidedly other factors which come into play when considering complex human behaviors. While he was described as being rather non-sentimental towards the animals he studied, he was strongly against the cruelty of vivisection and the fact that it produced obscure data. He in fact had the following inscribed on a monument to the many dogs sacrificed for science at the Institute of Experimental Medicine.
The dog, man's helper and friend from prehistoric times, may justly be offered as a sacrifice to science, but let this always be done without unnecessary suffering.
He died in Leningrad on February 27, 1936, at age 87. The second new subheading, Pavlov's dogs and the conditioned response, will deal with his digestive-related studies of dogs leading up to the observation and creation of the theory of conditioned responses. This subsection will greatly expand the current Wikipedia literature on salient information towards the creation of conditioned responses, as well as describing certain methods used for obtaining results and a description of the facilities in which the experiments were conducted.
While working in Professor Botkin's lab, Pavlov chose the dog as his main object of study. Due to the lack of scientific funding, stolen or stray dogs became the most easily obtained research specimen. Pavlov was aware of the immorality with having dogs stolen off the streets for him, but at the time was far too underfunded and poor himself to afford legitimately obtained research specimen. When he began his research at the Institute of Experimental Medicine, the dog remained his main, though not only research specimen. Pavlov's first large success in the field of digestion was the creation of the surgery which permitted sham feeding. The esophagus was severed and attached to fistulae, or holes leading to the outside of the body. Food simply fell out on the floor when swallowed, while separate fistula allowed the gastric juices produced to digest the food to be collected without being mixed with food. Pavlov noticed that not only did the stomachs of the dogs produce gastric juices with the absence of food in their confines, he also took notice of the fact that the stomachs secreted the juices if the dogs simply smelled, touched, or saw the food. The name given to these gastric juices obtained in absence of the direct ingestion of food was psychic secretions, implying that the glands producing the juices had a mind of their own. Being first and foremost a physiologist, the notion that there was a sort of psychic explanation behind the actions of the glands was not enough for Pavlov. Pavlov was very much a determinist, needing to find the true physiological cause behind the secretions. Based on the ideas of I.M. Sechenov, one of his greatest influences, Pavlov pursued the notion that behavior was a reflex of nature. Using a fistula into the salivary gland of the dog to obtain measured amounts of saliva as a response to food, Pavlov noticed that objects or stimuli other than the food itself began to trigger the same salivary response. In particular, the dogs began to salivate at the sight of the researchers who normally fed them. These researchers are said to have become a conditioned stimulus. It was this observation that led Pavlov to frame the theory of conditioned responses, also known as classical conditioning or respondent conditioning.
That scare tactic was not just a random example of me being a jerk or a scallywag. Its meaning will be explained momentarily. In order for a stimulus to become conditioned to a particular response, it must be paired with another stimulus, which naturally elicits the response. For example, the pairing of the visual stimuli of the researchers with the natural stimuli of the food, which when ingested elicits the natural or unconditioned response of salivation. In time, with successive pairings of the two stimuli, the sight of the researchers alone begins to trigger the salivary response. Did anyone anticipate the shark man appearing and screaming again after the beeps? Was that anticipation one of fear or unease? If so, the countdown beeps have begun to become a conditioned stimulus to the fear response you received from the shark man. The same principles apply to Pavlov's dogs, which learn the conditioned response of salivation to a number of different stimuli, such as lights and bells. The true deterministic and empirical science behind the conditioned response was studied as well through neural pathways. The neural pathway from the presence of food in the mouth to salivation was defined as follows. Meat is placed in the dog's mouth. The reflex path then, on a very basic level, goes from the taste buds to the medulla for interpretation and is finally sent back to the salivary glands to excrete saliva. Pavlov also recognized the role of the cerebral cortex, particularly in the conditioned response. The visual stimulus of the researchers becomes paired with the gustatory stimulus of food ingestion through associations made between respective visual and gustatory regions of the cerebral cortex. In 1903, Pavlov lectured on his paper entitled The Experimental Psychology and Psychopathology of Animals. It covered his ideas of conditioned reflexes and explained how they were an extremely important finding for psychology and in medicine as well. This final subsection will be the least revamped out of the three. I will simply highlight some of the major implications of Pavlov's experimentation, research, and theorizing. Pavlov's largest contribution lies in the field of psychology, in the notion of the experimentally backed theory of conditioned reflexes, which is still valid today. He also made it possible to study behavior as a function of the mind, objectively, through highlighting neural pathways. This was important as it outlined the mechanics behind a highly complex form of reaction of an organism to its environment. Pavlov stimulated much future interest and research on the cortex after defining some of its basic principles and laws through his experimentation as well. Finally, he discovered a quantitative method of investigating physiological responses and thus psychological behavior responses without an excess of confounding factors. This was important for the study of medicine, physiology, and psychology.